woman, don't come knocking around my door. Colored lights may hypnotize, sparkle someone else's eyes. American woman. Guess who? That's for my Canadian students here. We have one, just one?
Yeah.
Just one Canadian student. That's all that's allowed in class, is only one Canadian per class, because the Canadians are generally tend to be a little wild. You know, they're wild, crazy wild people. If you've ever been to Canada, it's like craziness in the streets, right? Don't you agree? I mean, they're nuts. They're crazy. When I think of crazy, I think of Canadian. Okay? They're nuts. Okay? But God bless our Canadian brethren. Okay? If it wasn't for Canada, the North American continent would just be boring. Okay? So Canada is really what keeps things rocking and rolling, baby, in North America. They are the heart and soul of North America. Okay. Now, wait a second. Oh! Yeah! American woman, listen to what I say! I am Canada! Yeah! All right, now, sorry, I got a little crazy, a little carried away. Okay, now, this is the next problem. We have to pretend, this is kind of like a war problem, and I hate doing war problems, but it's difficult doing problems that aren't about some kind of violent thing in physics, like for instance guns and cannons and projectile motion. And this next one is about a submarine that fires a torpedo at a ship. Okay, World War II, let's say. A torpedo fired from a submerged submarine is propelled through the water with a speed of 20 meters per second. That's the velocity of the torpedo. Okay, now, it explodes upon impact with a target 2,000 meters away. 2,000 meters away. Okay. The sound, if the sound of the impact is heard 104 seconds, so the velocity, or so the time of the 101, sorry. What did I say, 104? 101.4 seconds is going to be, oh wait a second, that is the time, right? So the time equals 101.4 seconds, okay? So that's the time to hear the explosion. Now, don't forget, who's hearing the explosion? So you have this ship, okay? And then you have the submarine here, right? So the submarine fires the torpedo, correct? Right? The torpedo is going 20 meters per second. Yes? Who hears, this is the submarine. Who hears the explosion? Who hears the explosion? The submarine. So, the submarine. So, time equals 101.4 seconds. That's the submarine, correct? Yes? This is going to be very important, so let's draw a better picture. The picture is going to be critical in evaluating this. This is what they want you to know. They want to know what is the speed of sound in water. They want to know the speed of sound in water. Okay? All right? They want to know the speed of sound in water. So the distance is going to be 2,000 meters, right? The time is going to be 101.4 seconds. What else was there? The velocity of the torpedo was 20 meters per second. Correct? Is that all the data there is?
Yeah.
Are you following along with me? Exercise 8? Yes?
Yeah.
Okay. So here's the boat. Okay, that's the boat. Here's the sub, right? So here's the torpedo. Right? That's the torpedo. Okay, now. How long did it take the torpedo to get to the boat? See, this is what you have to do. So let's try to see if we can think of what we have to do. I do this a lot, right?
It took him 100
Okay, right, but yes, correct. He's answering my question already.
Yeah.
You know, 2 points for the German team. Excellent.
I can also do the
Excellent, excellent. Right there, excellent. Now, we need to know the speed of sound in water, correct? Now, hold on. The Germans, I'll tell you, they're all over this. Excellent.
No, me.
Because
Excellent.
It's about German.
UAE, it's about a German sub. Is that what it's about? All right, let's not get political here, okay?
Of course.
All right, now, so we want to know the speed of sound in water. So does it make sense intuitively, if nothing else, that you need the speed of sound of the torpedo? How long did it take the submarine to hear the explosion? 101.4 seconds, right?
Yeah.
Right? So, but do you understand that, listen, I fire the torpedo. Fire one! Shh. Torpedo's away, right? Right?
Yeah.
Then I hear the explosion. Boom! But what has to happen before the explosion?
Then 1
The
second.
torpedo has to get to the ship, right?
Yes.
And then when it gets to the ship, then the sound of the explosion is going to travel through the water, correct?
Yeah.
All right?
Sir?
So does it make sense? If I know that the torpedo is going this fast over that distance, how long does it take the torpedo to hit the ship?
About 100 seconds.
100 seconds.
So that.
Okay, wait a second. Hold your horses there. Right? 100 seconds. So 100 seconds. Torpedo to ship.
Okay,
Right?
Yeah.
Because, all right, well, let's see. I know that V equals D over T. T equals D over V. 2,000 meters over 20 meters per second. Right? You see that? And that's going to equal 100 seconds. Now, yes, Jacob, he's dying to tell me. Yes.
I know. And so you have like 1.4 seconds of like travel of the sound from the ship to the torpedo. So you divide the distance by the time the sound travels from the ship to the torpedo, and then you have your final answer.
Very good. I know that's right. Very good. So, do you get it so far?
Yeah.
You get it so far? Yes, 100 seconds? Okay, so we know that it takes the torpedo 100 seconds to go from the submarine to the boat, right? What's the total time? What's the total time?
Total?
Yeah,
100.
101.4 seconds, right? So then, therefore, it's 1.4 seconds ship to sub, right? And I want to know that velocity. That velocity will be the speed of sound in water. Correct? Yes? So what's the distance between the ship and the sub?
Still 2,000 meters unless they move.
So what's 2,000 divided by 1.4?
1,428.6.
1,000.
428.57, so 0.6.
So 129, is that okay?
Yeah.
All right, do this. 1,429 divided by 340. 4.2. Is that what you said?
Yeah.
So, sound travels through water about 4.2 times faster than it does through air. You get that?
Yeah.
You sure? Okay. So just so remember again, what did I say? Didn't I say that speed is relative? Well, understanding it is also relative, right? Air, 340 meters per second, and in water, 1,429 meters per second. And what did we say, 4 point what?
4.2.
Times.
So the speed of sound in water is about 4.2, and in a solid, an elastic solid like steel, not lead, but steel, it travels even faster. Unbelievable. Canada, I'm telling you, the heart is beating in North America, and it's Canada, yeah! Crazy people, Canadians are crazy. All right, see you later.